Okay, let us have another topic for this quarter. It is all about arithmetic sequence. So we are going to use the formula for arithmetic sequence or the arithmetic rule, which is the a sub n is equal to a sub 1 plus quantity n minus 1 times d. And in this arithmetic rule, these are the possible unknowns. First is a sub n, which is the nth term. Then we also have a sub 1, which is the first term of the sequence. And we also have the third one. We have the n, or it is the number of terms in the sequence. And the last one is d, which is the common difference. So again, arithmetic rule is given by the formula a sub n is equal to a sub 1 plus quantity n minus 1 times d, where your a sub 1 is the nth term, a sub 1 is the first term, n is the number of terms, and d is the common difference. So let us have the first objective, which is to find the nth term or a sub n. So if a sub n is unknown, what are we going to do? We have example. Find the 11th term of the arithmetic sequence 3, 6, 9, and so on. So the first step is to find the given. In this example, a sub n is unknown, and that a sub n is a sub 11, or we are going to find the 11th term of the sequence. Okay, next we have a sub 1, which is equal to 3, and n is equal to 11. There are 11 terms in the sequence, and d, which is the common difference, that is equal to 3. So after finding all these values, we are going to substitute it to the formula. So given a sub n is equal to a sub 1 plus quantity n minus 1 times d. Then substitute, we have a sub 11 is equal to 3 plus quantity 11 minus 1 times 3. And then simplify 11 minus 1, applying the PEMDAS, we have 10. And then so we have now a sub 11 equals 3 plus 10 times 3. And then multiply 10 times 3, that is 30. Then a sub 11 equals 3 plus 30, which is a sub 11 equals 33. So 33 is our 11th term in the given sequence. Okay, so the next objective is to find the first term or a sub 1. So if a sub 1 is unknown, let us have this example. The 16th term of an arithmetic sequence is 48. If the common difference is 3, find the first term. So the same, we have to identify the given. So the given are the following. A sub n, which is equal to a sub 16. Okay? And a sub 16 is equal to 48. Next is we are going to find a sub 1 or the first term. And then we also have n, which is equal to 16, or there are 16 terms. And d is the common difference. The same thing, we have to substitute them to the given formula. Then a sub n or a sub 16 is equal to a sub 1 plus 16, quantity 16 minus 1 times 3. And then a sub 16, which is equal to 48, so we are going to substitute 48. That is equal to a sub 1 plus 16 minus 1 is 15 multiplied by 3. Next, we still have 48 is equal to a sub 1 plus 45, because 15 times 3 is 45. So to solve for a sub 1, we can apply the addition property of equality, but this time I'm going to transpose 45 to the left side of the equation. So positive 45 becomes negative 45. So we'll change the sign. So 48 minus 45 is equal to a sub 1. And 48 minus 45 equals 3. So therefore, a sub 1 is equal to 3. Or the first term of the sequence is equal to 3. Okay, moving on with the next objective, which is finding the common difference or the d. Okay, example. Find the common difference of the arithmetic sequence with a sub 3, which is equal to 11, a sub 5, which is equal to 19. So in this example, we are going to find the common difference. Okay, let us try to illustrate the example. A sub 1 is not yet given. A sub 2 is the same, unknown. A sub 3 is equal to 11. A sub 4 is also unknown. And A sub 5 is equal to 19. Or the last sequence, the last term of the sequence here is 19. Now, since in this example, in this given illustration, since there is no A sub 1, we can temporarily use the A sub 3 be the first term or A sub 1. So from above illustration, we can have a new illustration which is 11 as A sub 1, A sub 2 is unknown, and A sub 3 is 19. Okay, so for the solution, we can apply our new illustration, which is our A sub 1 is equal to 11, A sub 2 is unknown, A sub 3 is 19. So given we have A sub n, so we can make use of the last term, A sub 3, which is equal to 19. And then our A sub 1 is 11, and then our n is equal to 3. There are 3 terms in the sequence. And the common difference is unknown. So the same thing, we are going to apply all these values to the formula. A sub n is equal to A sub 1 plus quantity n minus 1 times d. Okay, next we have A sub 3, which is equal to 19. So we are going to substitute. Equals 11 plus 3 minus 1 is 2. So we have now 2d. Next, to solve for d, we can apply addition property of equality, but this time again, I'm going to transpose 11 to the left side of the equation, making 11 or positive 11 to negative 11. So 19 minus 11 equals 2d, and 19 minus 11 is equal to 8. That is equal to 2d. Then we have to divide both sides of the equation by 2. So we can eliminate 2. 2 divided by 2 is 1, making it d. And 8 divided by 2 is 4. So the common difference is 4. So in here, to check if our common difference is correct, we can add 4 to the succeeding terms. 11 plus 4 is 15. Then 15 plus 4 is 19, which is correct. Okay, so down to the last objective, which is to identify the number of terms, or n. So example, how many terms are in an arithmetic sequence whose first term is negative 3, common difference is 2, and the last term is 23. So we are going to identify the given. A sub n is equal to 23. And then A sub 1 is equal to negative 3. And then n is unknown. And then the common difference is equal to 2. So after finding this given, the same thing, we are going to substitute this to the arithmetic rule. A sub n is equal to A sub 1 plus quantity n minus 1 times d. So our A sub n is equal to 23, and then that is equal to negative 3 plus quantity n minus 1 times 2. And then simplify. We have 23 is equal to negative 3 plus n minus 1 times 2. So what we're going with, the quantity here on the right side is to distribute 2. So 2 times n and 2 times negative 1. So we have 23 is equal to negative 3 plus 2n minus 2. So next is to combine like terms. 23 is equal to negative 3 minus 2 is equal to negative 5. So we have now 23 equals 2n minus 5. So next thing is to transpose negative 5 to the left equation. So from negative 5, it will become positive 5. So 23 plus 5 is equal to 2n. And then 23 plus 5 is equal to 28, which is equal to 2n. And to solve for n, divide both sides of the equation by 2. So making 2 divided by 2, which is equal to 1. So we have now n. And 28 divided by 2 is 14. So the number of terms in the sequence is 14.